Okay, so let's continue on with the proof here. So now we start with the rank of the matrix. Okay, so we talked about the rank, the rank or the dimension of the mapping. Now let's focus on the rank of the matrix. So it says the rank of the matrix is the dimension of the column space. Okay, and the span of the set of its columns, which is given by this. So this notation. Okay, so we're taking the span of the set of the representative with respect to D, right, the basis in the range of h of beta sub 1 through h of beta sub 2 sub n, those vectors. And now to see that the two spans have the same dimension, we're going to recall from the proof of a previous lemma that said that if two spaces have the same dimension if and only if they're isomorphic. Okay, so from that proof of the previous lemma, that if we fix a basis, then representation with respect to that basis gives an isomorphism, which we denote by a mapping of representation with respect to D from W to R sub M, right? So it's going to, that maps to R sub M. So if you recall, if you remember that, under this isomorphism, there is a linear relationship among the members of the range space if and only if the same relationship holds in the column space. Okay, for example, that the zero vector is equal to this linear combination of the betas, right, or the h of betas, I should say, the mapping of the beta vectors, right, from basis B, if and only if the zero vector is equal to the linear combination of, of the representatives with respect to D of h sub beta sub 1 through h of beta sub n. So these two, right, equals zero vector. Okay, now, at this point, we just need to notice that a consequence of this is a subset of the range space is linearly independent if and only if the corresponding subset of the column space is linearly independent. Therefore, the size of the largest linearly independent subset of the range space equals the size of the largest linearly independent subset of the column space. And so the two spaces have the same dimension, which is what we're trying to prove. And we're done. Now, so this settles the apparent ambiguity in our use of the same word rank to apply both to matrices and to maps. And that's it.